4.7 Congruence and overlapping triangles. In this lesson, we are going to identify congruent overlapping triangles. This is going to be the reflexive property of congruence. It's going to extend our knowledge of that, and to prove triangles congruent using other congruent triangles. To do that, we use the congruent corresponding parts of one pair of congruent triangles to make other triangles congruent. So let's start out with an example here, identifying common parts. Now, hopefully you can see that we have two separate triangles here, and it says, what common angle do triangle ACD and triangle ECB share? So first thing we're going to do is find triangle ACD, and so that's this triangle right here, blue triangle, and triangle ECB is this triangle right here. And so where do those two triangles overlap? Well, if you look carefully, you can see that angle C is in both of those triangles. If we separate our triangles out, blue triangle comes here, green triangle comes here, and then we look at our triangles. We have triangle ACD and triangle ECB. You can see that angle C is common to both of them, and you can see that it was this angle up here in the first place. Now let's take a look at our triangles. Look right here. You can see in their name that they both share angle C. All right. Go ahead and pause the video and separate your triangles that you're asked to do and see if you can identify the common parts. If you drew your triangles, we are asked what is the common side in triangle ABD and triangle DCA. So we redrew, if you drew in your triangles in colors, this is where color really comes in handy. You can see that they overlap here. We have a reflexive property of congruence on a side. And if you separate them out, you can see that segment AD is the same in both triangles. Now, if we look at our naming, look here. We have an AD and an AD. So looking at the names will help. And then we are asked what is the common side in triangle ABD and triangle BAC, and we redraw those. And you can see here that your green and blue overlap on segment BA. If we redraw the triangles by separating them, we can see BA and BA, and look here in the name. There's segment BA, there's segment BA. So the name will really help. Now, the important thing to remember here is it has to fully overlap. Okay, it has to be complete in both of them. In these triangles here, the last ones we did, don't try to make these corner angles congruent because it is not a complete overlap. It has to be exactly the same side or exactly the same angle. So be careful. Use your color and your separating them, redrawing them, and the name to help you find these. All right, let's look at our next example. How do we use these common parts? Well, let's look at what we are given. We are given that angle ZXW, so I'm going to find angle ZXW, that's this angle right here, is congruent to angle YWX, so YWX, that's this little angle right here. Those angles are congruent. And angle ZWX, that's this big angle here. I'm going to put two things on it. And angle YXW, I'm going to put two on this big angle. Okay. So we can see that we have some congruent angles, but separating this might help. We want to prove that segment ZW is congruent to segment YX. So we are looking at this side here and this side here. This sounds an awful lot like CPCTC to me. We've got triangles and we want congruent parts. First thing I'm going to do is separate them out. So the left triangle comes over here and I'm going to remark my congruent angles. And this here and this here. This is really starting to look a lot better. And what do we know from up above? Look, this is where triangles overlap. So this is one of our common reflexive parts, right? And look in the name. We have WX and XW in our triangles, right? So we know that that is congruent to itself. That's a reflexive property there. So I see an angle side angle. So this is reflexive. The green is just a given. Dark blue is just a given. And so here I see angle side angle is going to make our parts congruent. So our first angle is given. We got a side from reflexive. Our second angle is given. We can make our triangles congruent by the angle side angle postulate. And then, because our triangle's congruent, we know ZW here and YX, they're in the appropriate positions, CPCTC. Okay, that's a nice little example. Why don't you go ahead and pause the video and see if you can do the next proof. Okay, this one took a little bit of thought. Now, we were told that these two triangles are congruent, so I separated them out, and because these triangles are congruent, I can mark all of the corresponding parts congruent. So I know these two triangles are congruent, so I just went around and used my color to mark all of the parts congruent. And then what I saw, I'm looking at, I want to prove that segment CE is congruent to segment DE. Well, that involves this little single triangle down here at the bottom. So I asked myself, what do I know? And that is just parts of these, so that is not going to help. I can't just use parts of those sides. But what I did realize was that these angles right here are parts of my two congruent triangles. So I redrew this little triangle down from the bottom here, marked those two angles congruent, and immediately saw that I have the converse of the isosceles triangle theorem. So my proof is that my triangles are congruent. That's given. I know these two angles are congruent because corresponding parts of congruent triangles are congruent. And then I can say that these two sides are congruent by the converse of the isosceles triangle theorem. So a very simple proof, but a little bit challenging to see. You really kind of have to work your way through and see, what do I have available that is going to let me use some postulate, theorem, or definition that I already know. So I like that one. That was a good problem. And don't be too upset if you didn't totally see it, but you should have tried to draw it out and see what you can do with it. Sometimes you just have to play with it. Sometimes you have to make mistakes and say, no, that's not going to help me. That's not going to help me. What else can I try? Okay, these problems are a little challenging, but you know that there are things that you can look for. All right, let's see what's next on our list. using two pairs of triangles. All right, let's look at this example. It says, in the design, E is the midpoint. Oh, those are keywords that we like. What does midpoint mean? It means two congruent segments. Midpoint of what? AC. So I'm going to go find AC. E is the midpoint. I can mark those congruent. Right? That's just the definition of midpoint. Come back. Definition of midpoint, let me mark those two congruent. Oh, and check this out. It's the midpoint of DB as well. So that means I can mark those two congruent. I see things coming together here. What are we trying to prove? We are trying to prove that triangle GED, so let's find out where that triangle is congruent to triangle JEB. Look at that triangle right there. Okay, is there any way to prove those triangles are congruent? Well, those first midpoint segments didn't do a whole lot for us, did they? Maybe. What can we do with this? Do you see them? I see vertical angles here. Okay, is that going to help us? What else can we do with this? Well, what if we extend that out and make those vertical angles? Then we could have triangles that are congruent by side, angle, side. Would that help us? Oh, I think it might. Let's try that. Okay, so we're going to redraw here a little bit. And I'm going to make, these are my two big triangles. And I can prove them congruent by side, angle, side. And if those triangles are congruent, then corresponding parts are congruent. Because now I can make these angles congruent, right, by vertical angles. Those are vertical angles as well. And what part of the two orange triangles are part of the two big triangles? How about these angles right here? So then what I end up with is we're given, well, this is definition of bisector, that those are congruent. I have vertical angles there, and these red ones are congruent by CPCTC. So now I have angle, side, angle. That'll prove those congruent. So that one was a bit of a challenge as well. Let's look at our proof. We've got our midpoint, definition of midpoint, that makes our sides congruent. There's our congruent sides. And here's our big vertical angles. So we made our triangles congruent by side, angle, side. And that let us make those two angles congruent by CPCTC, corresponding parts. And then we have the little congruent angles here in the middle because of vertical angles, which gives us our final triangles by angle, side, angle. So do you see how we used parts of those? We looked at our big triangle and saw that angle D and angle B are the same for both the big triangles and the little triangles, and so we figured out how to use those. All right, go ahead and pause the video and take a look at the next proof. See what you can see. All right, there wasn't enough room here to do the entire proof, but we can talk through this. Okay, we were told that all of this bottom stuff, I'm going to erase these for the moment. We were given these two sides congruent and these angles congruent. And then we look at it and say, well, we could make these bottom, like boomerang shaped triangles congruent using the reflexive property. So I was given these, use the reflexive property. I can make these two triangles congruent by side, angle, side. All right, so we've got side, angle, side there. And then this right here, oh, hold on a second. We're asked to make these two triangles congruent. So I did these bottom boomerang triangles because they share this side right here. So I can get that side by CPCTC. And I said, well, how do I get another side? And I noticed that this side and this side are part of these larger triangles. And they contain the green side and the blue angle, and then just this long side here that we can also get by reflexive property of congruence. So this is just a reflexive, and we can do this one by side, angle, side. So I can make these two sides congruent by CPCTC. So I now have two sides of these orange triangles up here that I can get by CPCTC. This second triangle, the second congruent triangles, is very similar to this first proof. And then what do you see here? So I can make pink side congruent, I can make red side congruent, and I see here in the middle, we've got another reflexive property right there. And now these triangles can be congruent by side, no angles there, the side, side, side postulate. So we had to make 3 sets of triangles congruent to get to that one. So we had to do the bottom boomerang ones to get this side in the middle here, and then we had to do the 2 big triangles that make up the left and right to get the top sides using CPCTC, and then just the reflexive property, which is always awesome, gave us the 3rd side that we needed. Now the next example talks about when you have multiple triangles overlapping, you might have to do a lot of separating. So let's look at this one. We are told that segment CA, so that's the big long one here, is congruent to segment CE, and segment BA is congruent to segment DE. Okay, that's the little part in there. So let's look at what we can mark. We have a big triangle. We have a bow tie triangle here in the middle. We have 2 smaller triangles that overlap to make the bottom. Can you see where all of these triangles came from? We have these 2 bow tie triangles in the middle. We have the big overall triangle, and then these 2 triangles down here at the bottom that overlap. So we have redrawn, and now let's label all of these. The first thing that we're told is segment CA is congruent to segment CE. Let's find out where that happens. That's here and here. Ooh, anything we can do with this guy? I can mark those angles congruent. That's the isosceles triangle theorem. Okay, are these 2 angles on any other triangles that we can mark? Nope, not on the bow tie. Those are not complete angles, but look, we can mark them here as well. And that was CPCTC that allowed us to mark those congruent. So those two congruent sides did a lot for us. All right, what is next? Segment BA and segment DE. Well, where do we find BA and DE? I see it here. I always need two. And it's also here. All right, that's just given. It's given on this one. It's given on this one. Okay. We want segment BX congruent to segment DX. We are trying to get these little pieces here. That's why we need the bow tie. We need to get these two triangles congruent so that that part is congruent. All right, well, let's look. What do we have? We've got an isosceles triangle here. That works in those parts. What can we do? Oh, look at these two triangles over here on the right. Where does that come from? That's that right there. So that's the reflexive property of congruence. So I can make these two triangles congruent. How? That's side angle side. Now, does making those triangles congruent do anything for me? Well, it gets me segment BE and segment DA congruent, but that's not quite what I need. What else does it do for us? It does these two angles right here, right? CPCTC. Where do those two angles show up? Well, those aren't the angles that I need. Are there any other angles that we get? What about these? Those are CPCTC. Does that help us out? Are those angles in any of our other triangles? I see them right here. They're in our bow tie. That's CPCTC. Anything else we can do with that? I see vertical angles here, and now we can make these two triangles congruent by, I see angle, angle, side, right? Angle, angle, side theorem. We'll make these two triangles congruent, and then once our triangles are congruent, these pieces are congruent by corresponding parts of congruent triangles being congruent. So let's look through the proof here and see what we see. All of that's given. Here is our, it's the wrong color. Here are our two angles, right, that we marked by our isosceles triangle theorem. And then we said these are the green lines. Right? This is the base of our triangles over here, the two right ones, the two on the right. And then we made our triangles congruent. That was our side angle side. And then these are our pink angles by CPCTC. We transferred them over to our little bow tie angles over here. And then we used our vertical angles, vertical angle theorem in the middle here, to get our angle, angle, side theorem, which let us get this final thing that we're after to do CPCTC. All right, pause the video, see what you can do with the next set of triangles. All right, let's talk through this one. I marked everything that I was given, told that these two blue angles are congruent, and then my purple angles are congruent, C and E down here. And I want to prove that the orange lines are congruent to each other. So that's the ultimate goal, is that these two orange lines here end up congruent. Well, how are we going to get those? First thing I did was I drew out all of my triangle possibilities. We've got the big triangle, and then we've got this little weird one here that's in the middle, and then we've got our little bow tie triangle down at the bottom. And I just started going through, and I marked all of the angles I could mark. The blue ones show up on these first two. Those are given. Angle C and E, the purple ones, they show up on the first one and the third one. And then I looked at my first triangle here, and if I use the reflexive property, I can use angle, angle, side to make the two big triangles congruent. And then I see that these sides right here are part of the little bow tie, and the bow tie has the sides that I'm after. Right? These guys right here, or these guys right here. But the bow tie has these sides on it. So I could make those sides congruent on my bow tie down here by CPCTC. And so now I have a given angle and a side. And on the bow tie, I've got vertical angles. On this middle set here, I really don't have anything. So looks like I'm not going to use that one at all, which is a possibility. We draw everything and then figure out what we're going to use. That's what Define Explore is all about. And then on this bow tie triangle, I can make them congruent by angle, side, angle, using my given, my CPCTC from my previous congruent triangle, and my vertical angles. And then in the end, I'll be able to make BD congruent to FD using CPCTC. Because once my triangles are congruent, all the corresponding parts are congruent. So you can see that these proofs are getting to be a bit longer than what we've done before. We're proving 2 or 3 triangles congruent so that we can use pieces of them to make other triangles congruent. So these are going to take some thought and some effort, but I believe that if you draw it out and take the time and think about it, you can do them. So have fun with the proofs.